Okay guys, so now we go to part D, which is the last part of lesson 3 of this lesson. So we'll define something called the common ion effect and solve questions on the common ion effect. So what does the common ion mean؟ الأيون المشترك، وبنفهم شو معناها. and effect اللي هو تأثير. So we'll understand what do we mean by the common ion effect on solubility، كيف تأثيرها على مدى ذوبان المركب الأيوني. So a common ion is an ion that is common to two or more ionic compounds. For example, imagine I have NaCl and I have KCl. So the ions here are Na plus, Cl minus, and the ions here are K plus and Cl minus. So both of them have Cl minus. الاثنيناتهم عندهم Cl minus. So we can say that Cl minus is the common ion، اللي هو ايون مشترك ما بين المركبين هذيلا. فهذا هو مفهوم الايون المشترك، انه ايون موجود هو نفسه في مركبين ايونيين. So the lowering of solubility of a substance because of the presence of a common ion is called common ion effect. يعني لما نمزج مركبين وفيهم يكون في أيون مشترك، فهذا يقلل ذائبية مركب معين منهم. فالcommon ion effect أو تأثير الأيون المشترك معناه إنه ذوبان أو مدى قابلية الذوبان أو كمية المادة اللي تذوب تقل بسبب وجود الأيون المشترك. So as we're saying, common ion effect means that the solubility is going to be lowered. Okay, the solubility of substances is going to be lowered because of the presence of a common ion. إنه تأثير الأيون المشترك معناه إنه ذوبان أو كمية المادة اللي تذوب قاعدة تقل بسبب وجود أيون مشترك في المحلول. شو معنى هالكلام؟ How can we translate this? Have a look here. Okay, imagine you have a solution, okay, of PbCrO4 in water. Okay, so imagine you have the following in water. All right, now what are the ions here? The ions of PbCrO4 are Pb plus 2 and CrO4 minus 2. So there is a reaction here, guys. There is a reaction at equilibrium. So PbCrO4 solid is going to dissociate into Pb plus 2 plus CrO4 minus 2 AQ. So this is the equilibrium reaction for the dissolving of PbCrO4 in water. Now, what do you think will happen if we add more CrO4 minus 2؟ يعني تخيلوا إذا زودنا كمية CrO4 minus 2 here, what will happen؟ المفروض the reaction will shift to the left. تذكروا الدرس الثاني تأثير ال changes of concentration on the equilibrium. مبدأ لو شاتيليي's principle الدرس الثاني. Okay, module 16 lesson 2. Because if we increase this one, the reaction is going to shift to the left. And if the reaction shifts to the left, then the amount of Pb plus 2 and Cr CrO4 will decrease and PbCrO4 will increase. شو معنى هالكلام؟ لأنه الرياكشن will shift to the left، يعني التفاعل بيروح لجهة اليسار. So I'm using these two، يعني قاعدين يتفاعلون مع بعض. لما يتفاعلوا مع بعض كميتهم قاعدة تقل. When they react together their amount is decreasing. And because it's going to the left we are making PbCrO4, making more of it. So it will increase. فلما يقلوا الأيونات when the number of ions decrease، okay, it means that the solubility is decreasing. معناها انه الذوبان حق هذا المركب قاعد يقل. ليش؟ لانه الايونات قاعده تتحد مع بعض وتكون المركب، فهو قاعد يتكون مره ثانيه، فذوبانه قاعد يقل. لانه الذوبان معناه انه يتفكك الى ايونات. Because dissolving or solubility means the ionic compound breaks down into ions. So if I'm actually making the ions react to form the compound, so the ions are decreasing. ولما الأيونات تقل, when the ions are decreasing, it means the solubility is decreasing. معناها إنه الذوبان قاعد يقل. Okay? So this is what happens, right? And actually, if we have PbCrO4 in here and we add to it K2CrO4, the CrO4 O2 minus is a common ion. فلما أنا أضيف هذا المركب إلى هني كأني قاعد أضيف CrO4، كأني زودت CrO4 اللي هو السؤال اللي حليناه هني. Okay? That's why the solubility of PbCrO4 is going to be decreasing. شوف solubility of PbCrO4 قاعدة تقل. It is decreasing here. كل ما قاعد أزود أنا من كمية ال K2CrO4. Because adding K2CrO4, the K2CrO4 has CrO4 minus 2. فأنا قاعد أزود كمية ال CrO4 minus 2 اللي هو هذا السؤال. What do you think will happen if we add more CrO4 minus 2? So this is called the common ion effect. لأنه CrO4 minus 2 هو أيون مشترك ما بين هالمركبين. فلما قاعد أضيفه قاعد يسبب لي هذا الشيء اللي شرحناه هنا. قاعد يخلي التفاعل يروح لجهة اليسار، فبالتالي قاعد يقلل من مدى الذوبان حق هذا المركب. That's why the solubility is decreasing as we add more K2CrO4. Okay, guys? So, the solubility of lead chromate, which is PbCrO4, becomes lower as the concentration of potassium chromate solution in which it is dissolved increases. يعني كل ما قاعد أزود أنا من هني هذا قاعد يقل. Okay? Potassium chromate is K2CrO4. The change is due to the presence of CrO4 minus 2 in both compounds لأنه هذا هو الcommon ion. وإنه solubility becomes lower، إنه الذوبان قاعد يقل، هذا هو اسمه common ion effect. لأن أنا قاعد أضيف common ion CrO4 minus 2. Okay؟ بس كيف أقدر أحسب الكمية؟ يعني بقل بكم؟ يعني كم بيصير ذوبانها الجديد؟ What will be the new solubility? The solubility is going to decrease. So what will be the new solubility? Okay? What will be the new solubility here? So this is what's going to happen. Okay? Let's talk about another example, which is CuCO3. Remember, CuCO3 had the following equilibrium reaction. Okay? Let's just show it here. Cu plus 2 plus CO3 minus 2. AQ, AQ. Okay? So, what do we want to do here? Remember, when we solve the problem about it, or you solve the problem about it, well, actually we solved the problem about it in example 17.5, we found that the solubility Okay, the solubility of CO3 was 1.6 times 10 to the power minus 5. كيف حسبنا هذا الشيء؟ Do you remember the KSP? KSP equals the concentration of Cu plus 2 times the concentration of CO3 minus 2. And here's 1, 1, 1. So we said the concentration of Cu plus 2 will be equal to CO3 minus 2 will be equal to S اللي هي solubility حق هذا المركب. Okay? Which was the solubility of this compound. And we said this one is S, this one is S, so KSP equals S square. وقيمة ال KSP كنا نحسبها من الجدول ناخذها هني. Remember, so KSP equals S square and S equals the square root of KSP. وبعدين ال S تطلع لنا. فكان طلع الجواب if I remember correctly this one. Okay? فهاي السوليبيليتي معناها هاي الكمية اللي راح تذوب أو الكمية أقصى كمية اللي راح تذوب من هذا المركب وتتحول إلى أيونات. But now suppose this is in pure water, like when we put this compound in water. But suppose we put this compound in ذوبة, we dissolved it in a solution of K2CO3. This is a common ion solution. Why? Because here we have CO3 minus 2 and here we have CO3 minus 2. فالمفروض هل الكمية هاي اللي قاعدة تذوب بتقل ولا بتزيد؟ احنا نعرف الكومن ايون افكت، تأثير الكومن ايون افكت المفروض ان الكمية راح تقل، كمية المادة اللي بتذوب راح تقل. So how can we calculate it? So we do the following, guys. Okay? So we do the following. As you know, in normal equilibrium, the amount that is going to be made of Cu plus 2 and CO3 minus 2 is going to be S. Both of them are S, right? هذا in water, هذا في المي. But now, in K2CO3, ال K2CO3 تتفكك إلى 2K plus CO3 minus. فهني في واحد وهني في واحد. فالكمية حق ال K2CO3 هي نفسها الكمية. Sorry, maybe we don't need this arrow. هي نفسها الكمية حق CO3. Okay? يعني الكمية اللي بتذوب من ال K2CO3 هي نفس الكمية اللي بتتكون من CO3 minus 2. Okay? لأن هني واحد وهني واحد في المعادلة الموزونة. So at equilibrium in water we have S and S. But in CO3 we are going to have S plus 0.10. من وين جاية ال 0.10؟ جاية من هذا المركب، لأن أنا ما ذوبته في المي. هذا المركب already كان فيه 0.1 مولر of CO3 minus 2. already كان فيه هاي الكمية. فالكمية اللي بتذوب اللي هي الإس لازم أزود عليها هاي الكمية. Okay? So in other words, the KSP is going to be S times 0.1 plus S اللي هي هني KSP equals the concentration of Cu plus 2 times the concentration of CO3 minus 2. The concentration of high is S. The concentration of this is going to be S plus 0.1. ليش؟ لأنه أنا ذوبت المركب في هذا المركب وهذا المركب already كان فيه 0.1 مولر of CO3 minus 2. لو كان ذايب في المي كان اثنيناتهم S. بس already المركب موجود فيه أو المحلول موجود فيه 0.1 CO3 minus 2. So multiply this equation. S here and S here. So 0.1 S plus S square. So this is a quadratic equation. هاي معادلة تربيعية. So you can solve it, okay? Because we have KSP, it's here. So we can solve it. So this is what we found, guys. Okay, هاي قيمة ال KSP اللي من الجدول هني. Okay, so we solved the quadratic equation. طبعا you can solve it using the rule which you learned in math, or you can solve it with the calculator فتطلع لك دائما إجابتين لأنه هي معادلة تربيعية. طبعا we cannot have something in minus, ما في كمية بالماينس, so the only amount is this one. So S in water, our solubility in water was 1.6 times 10 to the power minus 5. 1.6 times 10 to the power minus 5. S in the common ion solution equals هذا الرقم 2.5 times 10 to the power minus 9 mole per liter. يعني هذا لما نذوب الCu CO3 in water هاي الكمية اللي بتذوب. بس لما نذوب الCu CO3 in K2CO3 هاي الكمية اللي فقط بتذوب من هذا المركب. ليش؟ لأنه في common ion اللي هو CO3. It's a common ion. فالكمية قلت. وهذا هو تأثير الأيون المشترك. This is the common ion effect. Okay? Okay guys? So this is how it is. Now you can solve it. طبعا the first way of solving it is using the quadratic equation. There is another way to simplify your assumption or simplify your assumption. Now we can make an assumption. Now the KSP is very low. يعني هي 0.00000 and so on to 5. Okay? فهي الكمية قليلة جدا. يعني تكاد تكون صفر. So S plus okay, sorry, this amount is very low. Okay, which means the following: the S is negligible compared to 0.1. يعني لما نسوي 0.1 plus S هاي قيمة الS بتكون very small بحيث اني لما اجمعهم ممكن اقول انه الناتج راح يكون 0.1 قريبة من الصفر because the KSP is very small. So this one can be translated like this, and this equation can be S times 0.1 only equals the KSP, and then you divide, and then S will give you the same answer as we did here. Okay, it's going to be the same answer. يعني we assume that S is negligible, okay, is negligible only when KSP is very low. يعني مثلا to the power of minus 10, to the power of minus 9, to the power of minus 17, minus 10, minus 13, minus 12, minus 10, minus 14, and so on. يعني تقرب لك الإجابة. Okay. You can read the explanation here. Okay. And yeah, that's the end of that example. There is another example here. It says calculate the molar solubility of lead fluoride in 0.2 molar Pb in O3 solution. So let's check in water first. يعني إذا ذوبنا هذا المركب اللي هو PbCl2 إذا ذوبناه مرة في المي ومرة إذا ذوبناه in PbNO3. So let's check here. Do we have Pb? We don't have it. 1 second. Okay. Yeah. So what we need the KSP of PbCl2. طبعا تعطانا في الامتحان. So this is the KSP of PbCl2. Okay. So PbCl2 gives me Pb plus 2 plus 2Cl minus. Okay. Very good. So now this is 1 and this is 1 and this is 2. So we want the solubility. نريد نحسب السolubility. We need to know the concentration of PbCl2 اللي بيذوب that will dissolve. So if we say that this amount is going to be S, إذا قلنا إنه هاي بتكون S, so the concentration of Pb plus 2 will also be S, and the concentration of Cl minus is going to be, اتذكروا نفس ما حلينا في السابق, it's going to be 2S. So now the KSP equals the concentration of Pb plus 2 times Cl minus, which is equal to S times, so there is a problem here, guys, okay, that you should focus on. The 2 here, remember, we should put it in the equation, we should put it in the power, لأن هاي معادلة ال K equilibrium, ال KSP, so we should put it in the power. So this will be 2S to the power of 2, so KSP equals 4S cube, so the S equals KSP divided by 4 الجذر التكعيبي. اوكي، وحنحط الارقام، نحط ال KSP اللي هي قيمتها كم قلنا؟ 1.7 times 10 to the power minus 5. 1.7 times 10 to the power minus 5. Now, if we have this, so this is very important, okay? This thing here dissociates into, so Pb NO3 will break down into Pb plus 2 plus 2NO3 minus. So one here and one here. So the concentration of Pb plus 2 is equal to 0.2. Already موجودة 0.2 هني. فلما نحسب ال KSP, the KSP is going to be حق هذا المركب Pb plus 2 times Cl minus to the power of 2, and it will be the following: S plus 0.2 times 2S square. يعني هي نفس اللي هني، لكن الاس حق البي بي بلس 2 زودنا لها 0.2. من وين جاي 0.2؟ لانه اوريدي الوعاء كان فيه 0.2 مولر اوف بي بي بلس 2، فلازم نحطه هنا. اوكي، and then solve this equation to find S. المفروض الاس اللي هني تكون lower than this one. المفروض الاس اللي تطلع لكم في الجواب هني تكون اقل من الاس اللي موجوده. Okay, and that's the end of the common ion effect, guys, and that's the end of lesson 3. So we can solve quick questions here. So we said when QSP is bigger than the KSP, which of the following is not true? Okay, so all of these are going to be true. The solution is saturated, no precipitate will form, no change will happen, so a precipitate is going to form. هذا الشيء اللي مش صح، لأنه a precipitate will form when the KSP is bigger than the QSP. Okay, let me remind you of that. Where is this? Yeah, just to remind you guys, إذا ال KSP, sorry, there was a problem here in that problem. Sorry guys, 1 second. So guys, there was a mistake in the question, my apologies. So this is the proper question. When QSP is less than KSP, which of the following is not true? So we know that excuse me, if the QSP is less than the KSP, solution is unsaturated, okay, and no precipitate will form. Okay, so in order to answer this question, the answer is going to be a precipitate will form and the solution is saturated. So both of these are correct answers. اوكي لانه لما تكون الكيو اس بي اقل من الكي اس بي قلنا انه السولوشن is unsaturated و no precipitate will form. Okay, so just to double check here, as you can see, just for you to remember, let me show it to you. Okay, dokie, where is that slide? Yep, here it is. If the QSP is less than the KSP, the solution is unsaturated and no precipitate will form. تمام? And QSP is bigger than KSP, then a precipitate will form. فهو يقول لك يعني هذول الصح لما الكيو اس بي اقل من الكي اس بي هذول الصح انه solution unsaturated و no precipitate will form. هذا المفروض يحصل. But here they are telling you which one is not true. Okay? What is true if the QSP is equal to KSP? So this is okay. This is weird. These are the slides of the book. I don't know why they're showing this, but actually, if the QSP is equal to the KSP, nothing should happen. Okay, so nothing should happen. So if the QSP is equal to the KSP, let's see here. You should know it in two things. Nothing happens and the solution is saturated, like we learned in the previous slides. Okay, which is not true of the common ion effect. It is an ion common in two or more ionic compounds. Actually, this is true. It is lower than the solubility of the substance. It shifts the equilibrium to the right. So actually, the correct answer should be this one, because it shifts the equilibrium to the left. تذكروا is A plus and B minus. إذا زودت أي واحدة من هذيل اللي هي common ion, the equilibrium will shift to the left. Okay, and that's the end of our. So thank you for watching the lesson, guys. Wait. Okay, if you have any questions, you know how to contact me, and practice is key. You have to practice on these questions and try to understand what you are solving, not just memorize the way of solving. Okay, يلا بالتوفيق بإذن الله. I wish you all the best. Take care, guys.